Hello and welcome. So we want to welcome you guys here today in the medical and MR session here. So we're going to be here to talk about all different activities that we're doing in the medical space. So my name is Nicole Samec. I'm a healthcare product manager here at L.E.A.P. I have a background in biomedical engineering, so go STEM and women. And we're here to kind of talk about an intro, our speakers here who are going to be talking about different applications. So I'll start with an introduction to the session and kind of what we're going to talk about. And then we're going to have the University of Southern California Institute of Creative Technologies, which is a partnership we actually announced today with the Dan Marino Foundation, speak. And then we're going to have our Brainlab partnership speak. So kind of looking at Magic Leap as a whole, Magic Leap is a technology in which we're creating the next generation of compute. We're actually creating a spatialized computing platform. So there's many, many use cases we can do here, but what we're focused on in healthcare is actually the healthcare vertical. So we're looking at all sorts of things from education to wellness to healthcare to medicine. So we're trying to figure out the best way to utilize this technology in this industry. So kind of looking a little bit into our mission statement and what we're trying to do. We're trying to strive to merge medicine and technology. We think we can create some really innovative solutions to be able to improve the lives of consumers, patients, healthcare professionals, clinicians, all sorts of different individuals in the medical field and consumers and users just as yourselves, and basically help empower them to be able to make decisions in health. So if you think about healthcare, it's this full spectrum, right? It kind of starts with consumers and consumer wellness and education, and it moves into the patient side in which you look at assessments, therapeutics, different diagnostics, and then you can get all the way into the healthcare professional where we're looking at medical enterprise. So in that case, you're actually looking at healthcare professionals, your workflows, ways that you can help not only in the clinician side, but also how the clinician can help make decisions to inform patient care. So when we look at our technology, it has some really great value propositions. I mean, be able to visualize things in 3D in your real world, while you can still see your surroundings, is really valuable in this space. You're going to hear a great talk today by Stefan, who's going to talk about how you can actually take these medical images that are slices and view them as they are anatomically correct. So you can actually see this in real time while you're looking at the patient. You're also going to hear today from our great team at USC-ICT, where we're going to look at the other side of it. We're going to look at it's not only a visualization technology, it's also a technology that can understand the user and their environment. It has a really unique sensing capability in that you can actually use this to be able to adapt and change and really personalize different therapeutics to be able to have a better performance and outcomes. So you're going to have some really interesting talks that are going to come on today. We're very, very excited to see what is here in healthcare and in this industry. It's not only a platform for entertainment or gaming. This is really a platform that we really, truly believe can help impact lives, can help change lives. So we're excited for you to kind of join, and we hope that you're inspired. Feel free to reach out to us throughout the presentation or at the end of it. So introducing our speakers, first we're going to have Skip Rizzo, who is the director of the Medical VR Lab at USC-ICT. Then we're going to have Arno Hartholt, who's the director of R&D at the integration of USC-ICT. And then lastly, we will have Stefan Vilsmeier, who's the founder and CEO of Brainlab. Thank you.
All right. Okay, my name is Skip Rizzo. I direct the Medical Virtual Reality Lab at the University of Southern California Institute for Creative Technologies. Before I get started, I'd like to thank Nicole and the Magic Leap team for their faith and foresight in this partnership for developing the work that you're going to see here. The application is a mixed reality application that integrates a virtual human within the mixed reality environment, sitting across the table from a user that can be set up to conduct training job interviews for people on the autism spectrum. I think this is important when you think about people on the spectrum, oftentimes very capable, they can do the job, but because of whatever issues, they have a hard time with social engagement, and that doesn't work so well in a job interview. So by providing an engaging and a safe environment in a built real-world environment where we can hopefully promote transfer to the real world, we might be able to help these folks get over that initial hurdle for employment. And if you look at the stats with people on the spectrum, you're looking at about 80% are unemployed. So any way we can put a dent in that number is going to be appreciated by the users, their families, and society in general. So with that, before we do a deep dive, myself and Arno Hartholt will be my colleague. Before we do the deep dive into it, let's just do a little video that'll give you broad strokes on what we did.
For the population of people with autism and differing abilities, the unemployment rate has been over 87%. So it was time that something needed to be done in order to address that. And the partnership with the University of Southern California and Magic Leap is doing just that. I see that this technology will be their life partner or their skill coach partner that'll really allow them to take and prosper, not only just on the employment, but an entire life.
The Magic Leap Dan Marino Foundation project has been one of the more exciting projects that I've been involved in for a while. It allows us now to leverage the real world, but insert virtual humans into that real world in order to create training context for people on the autism spectrum. Instead of using a TV screen to deliver a job interview character, with the Magic Leap system, we can actually have a person sit in a real room, in a real job interviewing context. There's going to be better benefits, there's going to be better gains.
And it's immensely helpful for people to imagine better what it is like to sit across from somebody, to talk to somebody, to interact with somebody. And that the interaction between a real human and a virtual human, that's really key to making these training systems work.
So at Magic Leap, we're a very vision and mission driven company. Our vision is to amplify the best parts of you and to advance the human spirit. And our mission is to harmonize people in tech to create a better, more unified world. To me, that perfectly aligns with the work that the Dan Marino Foundation and the University of Southern California ICT are doing.
You know, Magic Leap is all about trying to impact lives. We're about trying to make a difference. And that's why we're so interested in working with the Dan Marino Foundation and USC ICT. Because it's not only something where we're trying to build an app, where we're trying to make awareness, we really are trying to impact these users in their day-to-day life.
A lot of us, we were isolated, or at least we didn't have many friends. At least I didn't have many friends. So we're always around the technology. That's how we connect with people. Definitely think with a DMF with Magic Leap will add a lot. It's really going to help us expand our reach of who we can touch.
Okay, well that about does it. Thank you. So anyway, what we're going to do is talk a little bit about our research using VR and now mixed reality, talk about the partnership, the future. Arno will then talk a little bit deeper dive into the virtual human work and the Magic Leap development, and then conclusions. So, as I said, we're part of the USC Institute for Creative Technologies, and over the years, our lab has focused on the design, development, and evaluation of clinical VR and mixed reality applications. So, interdisciplinary group that over the years has developed applications for psychological conditions, cognitive disorders, physical disabilities, and our work with virtual humans. So in the psychological domain, this is one of a series of simulations we developed for treating PTSD in service members from Iraq and Afghanistan. It's an evidence-based approach where you help a patient to confront and process difficult emotional memories in a safe environment. There's some already existing data that's supported, but a new study is coming out that's really going to hammer that point home soon. Back in the 90s, when we got started, this was something that we did for spatial abilities, for mental rotation skills, and we found that a very brief period of practicing interacting with these 3D holographic images, that we could actually show measurable improvements in visual spatial abilities, particularly mental rotation. And that got a lot of traction in the 90s. The problem was that system cost about $350,000 to deliver. You know, and as I watched that, I think to myself, well, you know, I'm going to dust that one off and probably run it in the Magic Leap, because we can do that kind of stuff, and we can do it well within the current state of the technology. This is a VR application, what a child sees wearing a headset, looking around a virtual classroom, designed for testing and training children on, that have attention deficit hyperactivity disorder, have to pay attention to what's going on the blackboard. Meanwhile, distractions. Teacher's going to answer the door, kid in the back just threw a paper airplane, you know, school buses going by the window. So an ecologically relevant environment to test children in a way where we can see how distraction affects their performance. Some more modern work that we've done with physical therapy, this is using a L.E.A.P motion sensor, a different company, on a headset, where now we can track hand movement for upper extremity rehab after a stroke or traumatic brain injury, and we can build game-based rehab in these environments so that maybe we can make it so that people do more of the rehab, make it so that it's more engaging, and a lot of other factors that contribute to the benefit of that, but it's an important area to address. On the virtual human front, what I'm going to show next is kind of the opposite of what we did for the job interview. This is an application we built a couple years ago for the School of Social Work at USC, a virtual patient application. You're going to see a novice social worker practicing a clinical interview with a...
Good afternoon, Sergeant Castilla. What brings you in today?
Well, my wife told me she thought I should talk to someone. She's been pretty concerned about me since a soldier suicided on base last week.
Did you happen to know the soldier?
Yes. He wasn't a friend, but I met the Marine once or twice. He seemed normal at the time. I guess I'm afraid I might end up like him.
Do you have any plans to hurt yourself?
No. It certainly crossed my mind, especially lately. I just need it all to stop. Sometimes I can't handle it.
So I like to say on that one that it gives novice clinicians a chance to screw up a bunch with a virtual patient before they get their hands on a live one. Anybody that's gone through clinical training knows that might be an important thing to do. And I think that's one that's like shovel ready for a mixed reality Magic Leap application in the near future. Finally, it's not just about that kind of training, but rather we can build healthcare support agents that are always available to people, and available to people that might not seek help with a live provider. So this was one we built for the Army during the height of the wars, where service members and veterans, you know, coming back from war, a lot of times they don't want to go see a shrink, they don't want to tell people about their problems. So we built this online virtual agent that they could interact with privately and anonymously to get information about PTSD, traumatic brain injury, all the invisible wounds of war, if you will, and do it in a safe way. Ask questions, learn. The character could ask thinly veiled conversational screening questions, and maybe give the user some feedback at the end, like, looks like you're going through some problems. If you want, you can punch in your zip code over here, and a list of providers will pop up in your neighborhood. And that way, you're not replacing good clinical care, you're trying to push it along, a toe in the water. I'll just let him introduce himself real quick.
Well, I'm not a real person, if that's what you're asking, but I'm based on the personality and experiences of real soldiers and Marines. I'm still just a piece of software, but I'm getting better all the time, so hopefully I can be a helpful piece of software to talk to.
Okay, so the virtual human work we've done in the past, typically on a flat screen monitor, sometimes in a head-mounted display, was really what led to the partnership with Dan Marino Foundation, Magic Leap, and USC. And the aim here was to develop this job interview training system where you could have a variety of characters, different job backdrops, and each character could be adjusted in terms of its personality, from soft touch to neutral to son of a cranky interviewer. And so here's an example. This character, this backdrop, soft touch.
I'm glad you're here. In a minute, we'll get into some questions about the job. But before we do, why don't you just tell me about yourself?
Now we could go on like that, we could make her cranky, or we could pick a different character and a different backdrop and ramp up the challenge level as somebody gets comfortable and practices and reduces their anxiety with repeated practice.
Okay, before I start rattling off questions, is there anything you want to tell me about yourself? Well, like I said, this place gets intensely busy. And to be honest, it is too much for some people.
So we use this at the Dan Marino Foundation. A number of the principals are here, Mary Parton and her team, and the voice for that cranky interviewer, Grace Ben, who's actually a very nice person, but she can do cranky well. But anyway, let's hear from a user.
It's a good program, and it teaches you how to do an interview, and it teaches you how to be in an interview situation with another person.
And did you see your performance improve? Did you get better?
I get better every single time I do it. I get better.
So that's the data from the first published study we did with Dan Marino Foundation, showing continued improvements with practice, leading to comparison before the training and after the training in live interviews rated by vocational counselors. That's the red boxes. So I think we're on the right path with this. It's just a matter of how can we disseminate it to make it more realistic and make it more available to a wide range of people that could benefit from it. And also, we're doing work with US vets here in LA, applying a variant of the system for veterans, and now working with Dan Marino Foundation for people that are incarcerated, juveniles who are incarcerated, about to be released, because we know that getting a job is the antidote, one of the antidotes to recidivism. Anyway, the project will move on, and probably in a fundamental way with the Magic Leap system. So in the future, I see what we're doing now is just kicking the door open a little bit for a wider range of social skills apps. I like to talk about the social skills obstacle course, where you walk around a building after you've gotten the job and characters pop up and engage you in social conversations, or you know, a variety of challenges, or as we're discussing right now, building an anger management scenario. So I see it expanding beyond just a job interview context. I see, if you look at our physical therapy work, it's what's missing, the haptic element that you see with traditional therapy. You're not touching objects or holding or grasping, and that's important. So with mixed reality, we can now start to endow physical objects of various types, weight, shape, texture, and give it properties that make it fun and engaging to interact with and try to promote more rehab. So I see that as a big area that we're going to pursue in the future. And finally, in the cognitive assessment and training, you see the spectrum from, you know, basic stimuli for training mental capabilities to more functional environments that are also used oftentimes with occupational therapists for people after brain injuries or stroke. And I see mixed reality as being the next big thing that's going to help support these kind of applications, make a difference for that population. I could go on for an hour on more things, but I'm going to pass the torch to the guy who really builds his stuff, Arno Hartholt, my colleague and good friend.
My name is Arno Hartholt. My background is in computer science. I'm the Director of R&D Integration at USC ICT, and full disclosure, also the CTO of VITA Technologies, where we transition and commercialize some of these capabilities. So Skip showed a lot of examples of what we do at ICT, and one way to look at it is that we create experiences that are novel, that are compelling, and that are meaningful, and we do that to train, educate, and heal people. And a lot of the work we do is research in individual areas, be they mixed reality or graphics or learning sciences. But many of these come together in these virtual humans. And virtual humans are interactive digital characters that can perceive real humans and respond appropriately, both verbally and non-verbally. There's a lot of research that goes into individual capabilities, nonverbal behavior generation, emotion modeling, cognition. What we do is we work with research groups, combine and integrate these capabilities. We add to that industry capabilities in order to get a platform that allows us to develop prototypes for research or applications like VITA. So all of this is coming together by working together with a range of different people: developers, programmers, artists, producers, designers, domain experts, but also researchers within hard AI areas, as well as, say, clinical psychology and other areas. By combining these different capabilities, by the different kinds of backgrounds, that's when you can create really, really interesting elements. And we've created a lot of virtual humans. Skip showed a view. Here are a couple of other examples. VITA is there. We can use virtual humans to educate children in classrooms. Standard virtual patients that you can interview. We can use these characters to train young officers to be better in interpersonal skills. What these really are is they are virtual role players. And that means that you can apply them in a range of different fields. And they don't even need to be humans anymore. You can see the little robot at the bottom here. We use that at the Children's Hospital to help disseminate information to parents about what are clinical trials and should you become part of it, yes or no. Now that is virtual humans. We've done a lot of work in virtual reality and augmented reality and mixed reality. I'm going to show a couple of examples for that, starting with a project we did started about 10 years ago.
Welcome to Gunslinger and the Clementine Saloon. Step inside and be transported to another time and place.
You're in Colima. Once it was a good place, but now it's a dying town.
There's something familiar about the locals left here.
I'm Utah. This here is my saloon.
They're the time-honored residents of any good western watering hole, the bartender, the bar girl.
My name is Harmony. Well, I'm in stress management.
Help yourself to any drink you want. We'll settle up before you leave.
So you can see an early example of mixed reality. A Hollywood set, screens that extend the real space into virtual space, virtual humans that you can interact with, a system that sees you, a gun that you can use, a lot of different elements coming together. And you know, you may see some similarities to a recent HBO hit show that you may be familiar with. And obviously we got our inspiration from the original book and movie. But recently one of the main actors, Jeffrey White, came by to talk with Skip about his work in virtual reality exposure therapy for veterans. He plays Bernard in Westworld, and it was great to have him there. He was so excited to see some kind of physical thing that exists that's close to what they're working on. But you also can see the limitations, right? It's screens. If you see the bad guy coming up to you on a screen, as you can see here on the top left, he will never get closer to you than that screen. So what happens if you want somebody to intimidate you? What do you want if you want this presence and this intimacy? So this is an old, I don't know, $50,000 prototype of a virtual reality headset back in the day. You can see that now, you know, they will take a step back. And if the character becomes more threatening and intimidating, they will shock and go back. So there's a lot of work we did here in terms of virtual humans and augmented reality and virtual reality. What does presence mean? How do you deal with personal space? How do you deal with looking at each other in the eye? All these elements we explored in a range of different elements. And that's where Magic Leap comes in, because now we open up a whole new frontier of capabilities that we can use and apply to virtual humans. So for VITA, as Skip mentioned, you can select your character, and these characters portray different kinds of jobs. Are you in a restaurant? Are you at a school? What have you. You can choose the dispositions, that you can start off easy and practice with higher difficulty levels, basically. Then you can talk to these characters, and now with Magic Leap, you can talk to these characters in a real room. And that's a big change, because what you want is to practice these kinds of interviews as if you are at a job interview. That means that you want to have a professional setting, you want to sit across from somebody, you want to look that person in the eye, and that's something we can do now. What we also added with Magic Leap, because of all the sensing capabilities in the device, we can sense the user and provide feedback after an interview about what they can do better. So I'll show you a clip of our current prototype, and then we'll take it from there.
Hey, thanks for coming in. How's it going?
Hi. It's going okay. Thank you.
Why don't you start by telling me about yourself?
Oh, well, my name is Grace, and I've been working at CVS for the past 5 years now, and I would really like to have the opportunity to work for Ash Hardware.
So compare this to the movie and the pictures we showed before. A user is sitting in front of a big TV. Now you can walk in, and the virtual interviewer follows you, looks at you. When you sit down, you sit across from them. You are having a conversation with a digital character who is with you in the real world, and that's a big deal. Show another clip here.
You got any questions for me?
No, I don't think so. I think that I think we're a really good fit. So I would really like to work at Ash Hardware.
Thanks for coming in. I've got to talk to some other candidates. I'll give you a call during the week if you get the job.
Oh, thank you. Thank you. I look forward to hearing from you.
So this is compelling. It's compelling to do, it's interesting to do. But the other phase that we added is the after-action review that again allows us to use the sensors on the Magic Leap 1 in order to provide feedback. So we start off with the user seeing an overall graph of how they did during the interview. This is a score of 1 to 10, a general indication of how well the person did. And we combine a couple of metrics, in particular gaze, speaking volume, and how quickly you answer a certain question. Now, for each of these individual questions that an interviewer asks, you can dig a little bit deeper and look at the data of that particular question. So here we have metrics per question. We're looking at question 8 at the moment. And all of these are aimed at a sweet spot. And I'll delve a little bit deeper into this in the next slide. But it's providing feedback about, okay, you can look a little bit more at the interviewer, you know, remember to blink, remember to speak up, all those kind of things. You can give specific feedback. Now, the next layer then is what is the actual data that goes into this? And this is more of a developer view, but it's a raw performance breakdown of, say, eye gaze. We can see if the user is looking at the character, yes or no. And we want them to make eye contact. We want them to look at them, but we don't want them to stare. So that's the sweet spot, is in don't stare at the floor, don't stare at the interviewer, but alternate a little bit. And that's the same for all of these areas. The same for head orientation, that you want to be a little bit alive, that you don't want to be static, you don't want to go wild, and the same with eye blinks. Remember to blink once in a while. Now, our porting efforts in general, we started about a year ago. We used Unity as our game engine. It was really easy to set up. Within a day, we had a prototype up and running, and then we could start iterating, working with all the stakeholders to see what do we want this to be, how can we sculpt it, what is the feedback based on that. When zero iteration came online, that was immensely helpful. If you work directly with the device, that can take a little bit of time, but doing it on your desktop is amazingly helpful. Colors you still need to do on the Magic Leap itself, and that is crucial because dark colors are meant to be transparent. So if you have black, that black is being occluded. So if you're a character that originally had black hair, black shoes, black belt, you see through the character, which some people find disconcerting. Gaze is important. It works the same way. You want to give feedback to the student that they need to have eye contact. The character needs to have eye contact and not stare the entire time. And lastly, occlusion. Knowing that a character can sit behind a desk, seeing them embedded in the real world, all those kind of cues sell the realism of this. So next steps, we're going to start user studies. We gather a lot of data, but now we need to validate, okay, what are the right values for gaze behavior, for blink behavior, and how is it different per different demographic. We gather user feedback, of course, from Marino, from their students, what works, what doesn't work, what can we do better. Over time, add more content. We have a lot of different characters, a lot of different interviews, and obviously take advantage of any new hardware and software that comes out, because as you keep hearing today, this is the beginning, and we will take advantage of it all. And the vision here is that this is not just a practice interview tool. You can use these virtual humans for everything. And in this context, think of a personal coach who is always present, is always with you, knows you, senses the world around you, and in real time can provide feedback about what you do well, what you can do better, and will always make sure that you become a better you. Now, to do that well, as I said in the beginning, you need to have a range of different backgrounds of people working together. You can see here the teams from Marino, from USC ICT, and from Magic Leap working together. So many different backgrounds coming together, and that's what you need in order to do this. You need to have a multidisciplinary approach. You need to have cutting-edge research, the latest in technology, but you need to have an aesthetic that's pleasing. You need to work with people that know the domain. You need to work with end users that can give you feedback about what works and doesn't work. And then a design that all fits it together into a holistic and cohesive whole. Only then can you create something that is novel, something that is relevant, something that is engaging, and ultimately meaningful. Thank you. So with that, I'm going to hand it over to Stefan.
Thank you.
Hello, everybody. My name is Stefan Vilsmeier. I'm here to talk about technology that can dramatically impact everybody's life in a good way.
Cancer, the emperor of all maladies. It is a frightening disease for which currently there's no cure.
My oncologist suggested a brain scan because I hadn't had that tested. There were 3 tumors. And actually, I was prepared to die.
We are unquestionably in one of the most dynamic and exciting periods of medicine for cancer treatment.
We really have to think about what their quality of life is going to be, and quality of life starts with what's up here.
I no longer think about dying, you know? I don't. And that's, I think, pretty dramatic.
Who in the audience has a family member or friend who is fighting their own personal battle against cancer? Raise your hand. So I think you can see that there's a number of patients struggling with life-threatening diseases, and Brainlab today has a technology that can impact those lives and millions of lives in a positive way. So, how do you get to devote your whole professional life to develop treatments for critical diseases? And, obviously doing that isn't the most obvious thing to do after school. So for me, it all started with my first computer, a Commodore 64, that I got when I was 15. And I was immediately interested in focusing on vector graphics, and I started programming 3D software and wrote a book about 3D software when I was 16. And that book went on to sell 50,000 copies in just the first year, resulting in my being invited by the University of Vienna to join them for some special computer project. And when I saw the first images from computer tomography and magnetic resonance tomography, I couldn't believe how this high precision from those images wasn't used in a more meaningful way for surgery. And for me, it was clear that software would provide the missing link. And I had started studying computer science at the Technical University of Munich, but I dropped out of college after 20 days. And so this way, I had no other chance but to succeed with what I had started almost 30 years ago. So this is how the first software from Brainlab looked like. That was before there was a Pentium chip or Windows 3.1. And so in fact, I used the Commodore Amiga for generating those images. Most people thought of that being for computer games only. However, the technology inspired me as Magic Leap does today to create something unique and special. This is how I looked like about 30 years ago. And at our first exhibit booth where we tried to sell through distributors, that didn't quite work out. And so I knew that I had to spend the money I generated from the book, about $75,000, to figure it out myself. I built an exhibit booth in my parents' house garage with the remaining few $1,000s and shipped about 800 pounds on a flight to the US. And were there with an exhibit booth to build the first customer relationships and sold technology all over the world. Today, there is more than 4,000 hospitals using our technology in over 100 different countries. 75% of the top 1,000 cancer centers worldwide use some Brainlab technology. So we achieved growth through continuously leveraging the technology at hand and by introducing new products. So to understand how Brainlab impacts the healthcare market and also how that can be relevant to you, I need to start by explaining how we manage data and enrich data. So first, we need to somehow grab and organize healthcare data, images from computer tomography, magnetic resonance tomography, that all depict very different aspects of anatomy and of the disease. And we can use our technology to tap into the hospital's information system to grab the data and anticipate what patient is about to be looked at so that we can prefetch the data. And we can organize and the data by detecting what information depicts the same anatomical situation, and we combine, fuse, and compare all that data. A core piece of technology is a unique, scalable, and flexible atlas that allows us to map the patient's anatomy by detecting every single feature. So we do that by distinguishing different types of tissue, and this way we actually make the whole anatomy computer and machine readable. And we leverage certain algorithms using AI, and this way we get hundreds of structures, thousands of landmarks, so we've labeled every single bit of tissue inside the diagnostic data sets we have. So this enables us to detect all the different structures consistently over, and hundreds of structures over a number of different patients. And we use some semi-automated AI-based tools to also segment the tumors. Obviously, before you kill cancer, you have to look at it and analyze it. And we can use that information to quantify the extent and progression of the disease, but also to visualize the anatomy in a very powerful way, almost like as you would see in a surgical textbook. And this gives us access to to individually manipulate all the different structures, like peeling off the different layers of an onion. And all the technologies I talked about can all run in the background, highly automated, and this is the key for creating better visualizations, and nobody has a suite of tools similar to that. And we're not just limited to the brain. There's many other structures, lung, liver, etc., that we can depict, and we use texture mapping for more realistic visualizations. As we want to combine that with the real world, realistic representations become very important as we use spatial computing. And then there's a number of tools and apps that Brainlab provides to depict different structures, like outlining a spinal tumor, where we also have baked in knowledge and certain rules. We can visualize fiber tracks and configure them, which are the telephone wires of the brain connecting the cortex, the surface of the brain, with structures deep inside. We can plan safe pathways into deep-seated lesions and visualize and simulate the approach without any collateral damage. And then there is also a cloud solution that basically allows us to aggregate data across a number of different patients. And the anatomical mapping puts all those different patients in the same frame of spatial reference. And we can integrate data from multiple sources within the hospital. We will provide very soon dashboards that allow physicians to analyze the data they use. And we can even create aggregation maps that allows us to look at statistical data customized to the individual patient. This is an example of resectability visualized in green of a tumor that we can generate across a number of different data sets. So all of that powerful data management we now leverage in a number of different technologies I want to briefly introduce. So why does it all matter? Well, healthcare is the area that represents the highest expenditure in society, and also an operating system is the #1 revenue generator at any hospital. At the same time, it's also the #1 efficiency leak that only standardization can fix. So the core of our technology forms navigation in the human body. The camera tracks the position of a surgical instrument like a GPS system. This is how a terminal in the operating room for navigation looks like. Over 4,500 of those systems are installed worldwide. And by tracking the positioning of an instrument, we allow surgeons to get the perfect opening of the skull just above the tumor and to simulate on the fly the perfect location and shape of your craniotomy and safely access the tumor, pass by critical structures. By tracking the tip of an instrument, we can gradually digitize and the different steps of surgery, and or use an instrument that want to align along a predefined pathway. This looks like a computer game, doesn't it? And we can also navigate a perfect cut and use it for placing an implant in the perfect position in the spine, in the hip, or also the knee. Then there's a number of different other sources in the operating room we want to digitize, such as ultrasound. If navigated and digitally integrated, it provides us orientation and also update of soft tissue. An intraoperative CT scanner is another ability to update tissue in the middle of an operation. And with all those precise spatial sets of information, we're able to use that to also guide a robotic arm to make a perfect alignment to a predefined trajectory. Then there is a central information hub that we call BUS that allows us to access and control all digital information in the operating room. It's like a digital switchboard that allows us to control and stream all video information. And this is something that we have deployed across all different subspecialties in a hospital. For example, NYU just went live with a new hospital where over 40 operating rooms have all been equipped with that technology. And in the operating room, an example for such a video source will be a surgical microscope, the most essential tool of a neurosurgeon. And I want to show how we can digitally integrate that and the first application of mixed reality that is today in use in thousands of operating rooms and procedures every day. And the overlay shows the exact extent of the tumor deep below and the way all the other critical structures wrap around the tumor. So now, if we want to bring that to life, we can increase the spatial orientation by flipping that plane in 3D space, and you get a true impression of the extent of the tumor as it extends below that surface. So I think you can start to see how the technology that Magic.Leap provides is the next extension to take the whole universe that Brainlab has created to the next level. And so that's why this is really a very exciting moment also in the evolution of Brainlab. In our vision, we want to first start with planning and show how we can map the anatomy of an individual patient onto a specific model that we can turn and simulate and use for planning procedures. If you use that in an intraoperative environment, or if you take another scan, we're able to use all this sort of automatic anatomical mapping in the background to make the skin of the patient translucent. You'll be able to just look at the patient from different angles as if you have X-ray eyes. In the operating room, we can bring this concept to also show the craniotomy before it was done and condense and integrate all the different information from different workflows. So we can make it sensitive and specific to a particular workflow. So together with Magic.Leap, to all of you, Brainlab is providing a development framework that enables you to focus on the impact that your applications and ideas can have, and Brainlab is doing the heavy lifting for you. So you can benefit from over $600 million that Brainlab has invested into creating the existing technology base without having you to recreate it. So you don't have to worry about the data getting into the system. We do that for you, and you can provide your own custom data and visualization layer on top of what Brainlab readily will provide. This is a chart that shows that there will be modifications also at the level of the of the Lumen SDK to drive specific needs of the healthcare market. And whenever you want to have spatial computing in the operating room, in the emergency room, in a radiation treatment room, we will provide you the framework to bring applications better and faster to market. This is an example of how to integrate that for those of you that program. I'm not able to explain that anymore because I probably was the worst software engineer to ever work at Brainlab, and it's a good thing that I'm no longer personally involved with our software. So it is the first time in history that a healthcare company is, instead of competing in technology, is trying to really provide a platform that can facilitate others to bring products to market faster. Over the last years, the entry barriers and the hurdles for having your own medical product have gotten tougher and higher, and we're trying to make that more easy. So we are trying to really make your applications fly. And here are the different components of that. First of all, there need to be a universal way of getting data into the system. It's not really feasible to have 5 different apps having 5 different ways of how the patient data would get into the system. So there should just be an ecosystem to ensure that the data is always there and everybody can immediately just select a patient and tap right into that. And then, of course, the tool like anatomical mapping is also crucial because it provides us something that is really unique and just can also give you much better and more meaningful data sets to be visualized. And then, of course, there's also the Brainlab Healthcare Cloud that is HIPAA compliant and safe, and these are all things that are very critical when developing your own applications. And then finally, there's the regulatory setup that is very complicated. So in order to bring a system to be for use in the operating room, that would be very difficult to do on your own, and we can't have 10 different companies all trying on their own to basically do that. So we as a company, in partnership with Magic Leap, can identify and analyze any modification that may be necessary to software and all the different regulatory steps, and identify how to best attack that problem. And then there's a readily available install base of Brainlab with all the thousands of hospitals that we have our technology in clinical use that are hospitals that we are digitally entrenched with, and they allow you to then have your application just on top of that and basically ride at the coattail of what we have created over the last 30 years. And then, in addition, there is a number of different optional apps that you can use for your use cases where required. And so there's a number of different systems and data that you can access through the Brainlab environment. And then, of course, big data and machine learning is another important frontier that we want to attack. Not a maybe no other development like maybe the artificial intelligence, the human genome have been maybe as impactful as I think spatial computing. And I want to show how Brainlab has just brought all the different technologies together.
Retrieving CT scan. Performing anatomical mapping. Fibers. You can now walk inside the patient's head.
So the demo was just offering you a glimpse into what is possible, and we can't wait to work with all of you to change the world. And I think this is like really a very exciting event. And so let's just really start to even jointly turn healthcare completely upside down, and the future has just begun. Thank you.
So we would like to thank everyone who came today. I'd like to thank again all of our speakers. Maybe one more round of applause for all of them. As you can see, we're very excited about where we can go in this field. We hope that this really inspired you guys to see all of the many, many applications that we can do to actually help people and really improve lives. We'll be outside if you guys would like to come and ask questions, and enjoy the rest of your time at LEAPCon.